Alright, welcome back to Meteorology 101. We're going to go through the weather charts, um, look at some satellite radar, go through the synoptic situation, and just see what we got going on. So, currently in southwest Ohio, we're pretty much all high clouds. We got a mixture up there. It looks like cirrostratus, cirrocumulus. There's a little bit of cirrus went through a little bit earlier, and it's all base is about 25,000 feet. I'll show you how I come up with that. And I'd say probably broken skies, at least 5/8 of the sky covered. So that makes it broken. It does give it a ceiling at 25,000 feet. You look at the moisture on the charts, I'll show you, like I said, how I come up with that. It's 25 to 27,000 feet is what the thickness of these charts or these clouds are. So current temperature 74 degrees. We're at 45% humidity. That's decreasing with a dew point of 50. And pressure is 1,011 millibars, staying steady. And our winds are out of the south, about 3 miles per hour. So let's get pull a surface chart real quick, and we'll get a idea of what's going on with the surface pressure. See where we are on that on our pressure. We're at 1,011 millibars southwest Ohio, so let's see how accurate that is. Pretty close. Right here is 1,012, and then we have a low pressure system over the Central Plains right there in eastern Colorado. That's I'd say probably gonna be pushing to the east. It looks like it's kind of the way it's wrapping around that high pressure system. It's just kind of running into that high pressure system, so we should probably see some winds out of this. Winds out of the southwest start picking up if that high pressure starts, low pressure starts pushing into the high and closing those isobars a little bit tighter. Get that pressure gradient a little bit tighter. Start seeing some wind gusts. So we'll pull up current observations over there and see what kind of winds we got. Like I said, right now we're at about 7 miles per hour. Where I am, we were just at 3, so winds sustained at 7, so it might start picking up here in a little bit. Let's pull up the surface obs. You got the subtropical high semi-permanent pressure system over the Atlantic. That's pretty typical this time of year. So any of these systems, these low pressure systems that develop, push to the east, they run into that high, they have to go up around that high. They can't push it out of the way. If that ridge weakens, then they can let that low pressure system stay to the south. But the steering system is going to be your mid-flow on your steering of that low pressure, and it's just going to push pretty much into that high and then start pushing to the northeast. So it looks like a lot of stuff going on down here in Texas, eastern Texas, like marginal VFR conditions. Ceilings are between 1,000 and 3,000 feet. So we got there's a ceiling at 1,200 feet reported on that. We got 73 degrees, dropping down to 60 in north central Texas. So we got something else going on there. Maybe a little frontal system or a little bit of rotation. We see if you look at this, let me pull up the get my drawing tool out here. Alright, so if you look at the winds out of the south, then out of the southeast, we got that rotation right through here. Definitely some rotation right through there. So we got a little bit of a troughing through this area. So that's probably why we're seeing all these lower ceilings and all that cloud cover. So we'll go over to the satellite and the radar in just a minute. We got lowered visibilities with looks like mist. 2.5 miles visibility, 2 miles visibility, 5 miles visibility. That's all mist right through there. Dropping those visibilities, and then the lower ceilings. So definitely that troughing looks like that's causing all that. So let's go over to real quick. Let's get to the radar. Let's look. We'll see what we got for on the national radar. Let's go to the satellite first. I want to see what we got for clouds. So say we got significant cloud cover through the southeast United States, over the Great Lakes region, and to the north. You get that trough. It looks like an inverted trough coming out of that low pressure system, well to the north. You can see a wind shift right through here. It's pretty strong, so maybe a stationary front pushing through here. We'll see if there's any. Let's go here and throw the temperature lines on here real quick, the isotherms, and see what kind of temperature advection we have. So if we would have any thermal advection, we do got where those isotherms cross those isobars. We can say there's definitely some warmer advection in that area, and then maybe a cold front dropping back. If you look down through this trough, we got that wind shift right here, so we could bring that cold front back and wrap it around back into this trough coming out of that low pressure system. So we'll have to see what's going on right here too. If there's another, maybe it's a prefrontal trough that's pushing through that area. So like I said, you can definitely see that rotation. Maybe even like another low pressure system developing a little bit further to the south, just over eastern Texas. With the kind of check that out too. We'll pull up the models and everything and see what's going on. Alright, so with the national radar, do got some significant precipitation over eastern Texas into Louisiana, Arkansas, and then southeast Louisiana pushing up into Mississippi. So that's a pretty good system there. We got the low over the Central Plains, and then, like I said, if there was a frontal boundary stretching up around that high or dropping down with that warm air advection, we got over the Great Lakes region, definitely some precipitation there. And then to the northwest, just over the mountain range, you can see the higher elevations getting a little bit of snowfall, and then all the instability over the north central U.S., over North and South Dakota. So let's get a satellite. Let's go see what we got. If we can pick out these clouds. Like so, we got cirrus going through. Pretty much all cirrus going through southwest Ohio. So let's get the satellite up and we'll see what's happening there. Okay, so on the satellite, definitely see some rotation over eastern Texas. It's like into Arkansas. What that line is right there is a little trough or boundary right there pushing to the northeast. You see the ridging right there, the cirrus runoff of that system. Right here over southwest Ohio, you can see all the there's where that cirrus that we're looking at through our dash cam there. Like I said, low pressure here. Maybe the jet stream ridging right there. We got the high pressure out to over the Atlantic. We got the cirrus blow off over the southwest. And then if you look at the lower levels right there, you can actually see there's low clouds hitting those ridges in the mountains and developing over the mountains is kind of remaining stationary just all through this area. So here's all of our snowfall over the northwest. Our low pressure pretty much dominated this whole area through the central U.S. So you can have short waves off that around that low pressure system that are just causing different instability, areas of instability there. So looks like a finger of the jet right there, maybe some ridging right there. So we'll get an idea of what's going on. Let's put we know we got that low pressure system, we got the high pressure ridging over the east coast. So North Carolina, pretty much North Carolina, Virginia, all the way up into Ohio, northern Indiana, Illinois. It's all that cirrus blow off over that ridge. All right, so let's pull up a local radar. This is actually in Arkansas. Let me get my screen up. Okay, so that's over Arkansas. We got all that precip pushing through. These are all the observations along with that radar site. Let's go over to Texas. Here's Dallas Fort Worth. See if we see anything come up on this. Looks like nothing. Pretty clear there. Here's Shreveport, Louisiana. Now we're getting into some pretty significant precipitation. They're currently running heavy rain, mist, few at 900 feet, broken at 4,500 feet, overcast 7,000 feet. Lightning in the distant east and southeast. So they're seeing lightning in the east and southeast right there from Shreveport. All that stuff's already pushed through them. They're still getting heavy rain, but they're getting lightning strikes to the south and southeast. So definitely major unstable wave right there over eastern Texas into Louisiana. You can pretty much see that. Let's play this loop. Download a loop and get this. See if we can see any rotation in this. I would have to say maybe a little bit of rotation right there, and then that boundary just pushing through right through Shreveport. So. All right, that got pretty heavy. Died off a little bit. Shreveport got some pretty heavy rain, and then you can see these little bands of precipitation pushed through ahead of that. So, like I said, you definitely got like a shortwave development right there with just the minor shortwaves that are going around that system. So with all that troughing that we picked up on the surface chart, you can see these little lines. That's just like little shortwave troughs right around that area, low pressure. So there's looks like some low pressure developing around that, just right in that area, eastern Texas and Louisiana. So if we look at our wind directions, we go to the last shot. You can definitely see rotation here. Winds out of the east, winds out of the south. So it's crossing there. There's a thunderstorm reported. Winds are out of the southwest, and then winds are up to the north, winds are out of the east. So, I mean, you definitely got that rotation through that area. All right, let's pull up. Let's go back to our charts real quick. We'll go a couple layers up. Actually, let's go to. Let's see if I can get into you. First off, we're going to go look at the sounding for Wilmington, Ohio, and we're going to show where we got the cloud heights. All right. So here's our scootee for Wilmington, Ohio. This is for 12Z. It's 8 o'clock in the morning today. If we look at, we did have an inversion this morning. I didn't see any fog, so it wasn't really any significant moisture at the surface for that to cap off and then create any fog conditions. May have gotten some valley fog or something in the valleys around the area, but other than that, nothing that would have significantly dropped visibility. So temperature decreases with height. Small inversion, just under 700 millibars, which is 9,800 feet. So about 9,000 feet, 9,500 feet. Slight inversion there. But if you look at the from the temperature to the dew point, if we look at the spread there, we don't have anything really significant for moisture. I mean, you're looking at each one of these, there's 0 degrees. See if you can see that. There's your 0 degree line. There's your 10 degree line. That's minus 10. And then here's your plus 10. So if you look at these lines where we're crossing over, right at 650 millibars to At 650 on that one, you were looking at about 12 degrees, so you're not going to have any moisture there. That's why we're seeing all the high clouds up here, right here at 350 millibars, 300 millibars, right there, 350, and then maybe some right there at 400. So at 400, you're about 23,500 feet. We'll clear this out. So still pretty good gap right there. Right here's where we're going to have most of our moisture. You're about 1 degree there, and then 2. So just right at the 5 degree difference on between the temperature and the dew points. That's what's going to give you significant moisture. 5 degrees or less on the dew point depression, the difference between the temperature and the dew point, and then that's where your cloud layer is going to be. So 350 millibars, we're right around probably about 26,000 feet, 25 to 26,000 feet at 350 millibars. So at 350 millibars or significant moisture, we're going to be right around 25 to 27,000 feet on where that moisture is. And then that's going to extend up right through that layer right there. 30,000 feet. There's our temperature, dew point. You're hitting about the 6 degree difference. So you could have a little bit of clouds at that layer, but once you get above 5 degrees on the difference of that, then that's when you're a little bit too dry. So you like to see 5 degrees or less on the temperature on the dew point depression. Alright, so that's how I get my cloud heights. About 25 to 27,000 feet. That's what we're looking at on our camera right there. And that's all cirrus, spread out, cirrus, stratus, cirrocumulus. Alright, so we got the low pressure system over eastern Colorado, inverted trough. So you can see the wind shift. Get rid of that. We got winds out of the northeast, winds out of the southwest, winds out of the northwest. So you can see your rotation right there. There's your inversion. Now you got a wind shift right there. So now we could say possibly some warm air advection right through that area. See what we got for temperatures. Dew point 66, 67, 55. So we got a pretty good drop there. 60, 67 to 60, 69 to 53. So here's our warm sector. Take all these boxes, anywhere there's temperature advection, where they cross the isobars, and color that all in, and that is your warm sector. Really not a lot going on down here. We got these isotherms right through there. That one's going up. So we don't have any real significant moisture advection here. Maybe a little bit further to the south. But we're kind of running parallel with those contours, so there is definitely some little bit of warm air advection right there. So that's giving us our lower clouds all through there. It's getting a little cluttered. So all through here we got our low clouds. You can see all that. There's the red, that's the lowest ceilings or lowest visibilities. The blues medium, and the black is a little bit higher, but it's still significant moisture in a cloud cover. Let's go to let's get rid of this. Let's go up another level. We got this low pressure system closed off. We got that little bit of a unstable wave developing over eastern Texas. So let's pull the 850. Try to bump that up on the more populated on the plots, because so many balloons are let go throughout the United States to give us this data. So we definitely got the pretty strong ridging from the high pressure over the Atlantic. Ridging over the northeast, you can see that it stops the moisture on the east side of the mountains and pretty much on the east coast there. And then we got significant moisture to the south, all the way over eastern Texas, Louisiana, Arkansas, all the way up into Missouri. So that pretty much matches up with our rain, thunderstorms that are all pushing through Louisiana right now. So you can definitely see you got warm air advection. Let me get to I can draw on this thing again. We got, here's the isotherms at the 850. It's about 5,000 feet. So now we got the winds out of the south, pushing all that warm, moist air to the north. And then we do got a little bit of rotation right there. Let's go clear this out. So if you look at winds out of the southwest, out of the southeast, these are pretty much northerly, but you can say you got some ridging or some troughing right through there, and then that's going to cause instability for eastern Texas and Louisiana, right where those thunderstorms are moving through. So it makes perfect sense for the data. So the low pressure is still closed. This was over eastern Colorado. Now it's stacking up to the north. Over Nebraska, South Dakota. We still got a pretty significant low pressure system, but let's look at these winds real quick. Where this is placing the contours. Here's the wind coming out of the northeast, southwest. So we're almost pretty much rotation right in that area. So we can drop this south. I'd like to see an easterly flow to close that loop, but I would push that a little bit further south. Maybe got a little stacking going on. We had that low over eastern Colorado, and then maybe being, see, there's no data there, no data there, no data there. It's just not enough data to really tell. But if you look at that low, we're pretty much almost vertically stacked, I would say, over that, over eastern Colorado. Let's go up to the 700, see if we still got a low pressure system there. We'll pull a vorticity chart at the 500, pull the 500, see what kind of support we have there, to go up to the 300, 250, see what jet support we have for that system. And then we'll go to the models and see what how this system develops over Louisiana. You still see we still got significant moisture over eastern Texas, Louisiana, and Arkansas. So all those thunderstorms, we got moisture all the way into the mid levels at least right now. So we'll go up to the 500 and see if there's still moisture there. I would say there is, but since those are pretty strong thunderstorms. See if I want to pull that radar up to see if there are any warnings out. Let's do this real quick. Let's go back to that radar. Alright, there's one warning for coastal waters off Louisiana. So that's the only warning that's out there right now. And if you look at this radar, you can see pretty much rotation all through these cells that the radar is indicating. So they're just indicating rotation through those. We can pull up another radar. It's awful close to this radar site. We pull up another site, but I can pull up another radar and do some cross sections on that stuff. See how high it goes in the upper levels, and we can really break that down if we got time. Let's stick with what we're doing right now. Let's go back to let's see here, New Orleans. Alright, so let's get back to our charts. Alright, so like so we got significant moisture, 700 millibars. That is right around 10,000 feet. So we're pushing up into the mid levels. Now the low pressure system, let's go look at this real quick. We got a wind out of the north, southwest, southwest. That up there is going more southwesterly too, so it flows kind of like that to the north. But we got this out of the north and northwest, then shifting around. So we got a significant trough, but if we look right here, we got one out of the southeast. That's going more southwest, southwest. So we got troughing. There's a shift right there. Alright, so it looks like we got some troughing right through here. That's all staying to the north and then going through the from the southwest. So pretty deep right here. So we got a pretty deep trough. I'd say just I don't see that close low. We got a warm pocket right here though. This 8-degree isotherm. So our low pressure system probably still right in that area, just hanging out in that trough. So we got the rotation right there. So vertically stacked. Still got some pretty good thermal advection through the northwest though. Real good thermal advection. So that instability through all that mountain range, everything pushing down, the moisture pushing into the upper elevations, causing all that snow and that rainfall in that area. So we still got the significant moisture in the upper levels there. We still got the significant moisture here. We got our isotherm, a little bit of a weak advection to the south. So that's pushing up into that area. What do we got going on here? Nothing's right there. So, and then that thermal pocket right there. So it's that low pressure, warm core low, is hanging out right in there in the mid level. So we're at 700 millibars, right around 10,000 feet. So let's go up to 500 and see what we have. Then we'll do the vorticity chart after this at 500 and see what upper level divergence we have. So still significant moisture over Louisiana. So our isotherms are becoming more parallel to the contours. They're crossing a little bit, not much, but definitely got that significant moisture over Louisiana. Still over the northwest. So winds that blow counterclockwise around the low and then into the low. So our low pressure system was over Colorado, pretty much vertically stacked. We're still showing this troughing right here for pressure. Isotherms are crossing the contours, just some weak thermal advection right there. So stacking back off the off that low that was over Colorado, showing some weak thermal advection right there. So definitely some instability in that area, and then definitely that instability right there. You got a 40-knot wind, you got 35 to 40-knot wind right there, 45 knots. So you start pushing all that moisture out of the south, right up back up into Arkansas. So we're still pretty unstable in that area. You see the ridging there, but still warm, moist advection from the Gulf Coast. So even in the upper levels, so there's all of our rain, thunderstorms in the upper levels in that area. So we're still no significant moisture over southwest Ohio. So we're not really, we don't see the clouds at that level. Like I said, with the Scooty, we just got a lot of Syracuse out there right now, but that's all higher elevations. So that's why we got all high clouds today. All right, so if we look at this, we got there's the positive vorticity. Here is right along the winds, the 500 millibar positive vorticity advection. I mean, these are parallel right here, so we don't have it there. We do have this area right there, right over Arkansas, eastern Texas, Oklahoma, positive vorticity advection. There's our upper level divergence and our thunderstorms. So to the west, we have positive vorticity, and then positive vorticity advection ahead of that. And then we go into negative right there. So positive vorticity advection in that area, creating instability over Utah, and any precipitation that's being causes from that. And then we got some pretty strong stuff up to the north, though. That was a low pressure system that moved out. You can see the ridging, then the troughing. Now we got that large area, that low pressure system that moved out of the area. Pretty much what moved through and gave us that frontal boundary. It moved through and gave us all that weather we had the other day. There's heavy rains. So, but you can see right there, instability, upper level divergence over right over Arkansas. Okay. All right, let's go look at the jet stream. All right, we are at 30,000 feet. All right, so still got the troughing. We still got significant troughing right here through over eastern Texas and Arkansas. So then we start moving on to the ridging. So now we have troughing over that area, ridging over that area. So now we still got that rotation right in that area. And then we can see the jet finger about 50, let's see what we got right there, about 80 knots right there over Louisiana. So we have our exhaust, we got our jet support for that system, and then pulling all that moisture out of this thunderstorm. So let's see what let's go back over to, let's pull a 300. Let's run a 300 moisture, isotherms, pressure. See what we got going on right there. So significant moisture over Arkansas, Louisiana. Got a hole right in the middle of that over Tennessee. And then significant moisture all to the north, right there in the central. So that's all the high clouds, 30,000 feet right here. So it looks like a little bit of a clearing right there over Tennessee, northern Alabama, Georgia. We got a 90 knot wind going up into Arkansas. 40 to 90. So Here's another thing you look at when looking at these winds going 40 miles per hour or 40 knots, and then jumping to 90 like that. Now you got some speed divergence. So there's more wind going out than there is going in. So you got upper level divergence in that area. So still supporting those thunderstorms is basically what that means. Like I said, significant wind shift right here, supporting the rotation for a trough. So we got troughing, still pretty good instability in that area. Eastern Texas all the way up. So as far as that low, that was over eastern Colorado, kind of ridging right there. Here's the troughing to the back of that. So now we're kind of with the low, and we're stacking back to a trough, and then those isotherms are becoming more parallel with the contours. So now we're not really don't have any significant instability there. Just trough, upper level support for that low pressure system. Still reached to the upper level, so still has significant moisture in those upper levels, but we didn't have a lot of moisture in the lower levels there, that area. So if you look at even over Ohio, we still got, now we have all this moisture. We're at 30,000 feet, so 25 to 27,000 feet, we are picking up moisture. If you look at Wilmington, Ohio, they launch a balloon every 12 hours. This is one of them that is actually clear. So they're not showing any moisture at 30,000 feet like this chart. This chart is basically just representing 60% humidity at these levels. So that could be significant. That could be significant for cloud cover, but we're not seeing it right here. That's pretty much clear. So 25,000 feet, a little bit below that, we do have the moisture. Now that's pretty much what these charts are picking up too. So, all right, let's go with let's go to the forecast models real quickly. Let's go back to the surface. I want to go back to just look at the surface chart, and then when we go to the models, we can see what we're working with for what systems and how they're developing and how the models are going to make them, put them out there. So now we got the low pressure system over Colorado. You got moisture advection or temperature advection behind that. Definitely rotation here. Right there. So the troughing moving through Louisiana. We'll have to give and see if there's a low pressure system pops up right there on the models. See what that does with that. Like I said, the high pressure semi-permanent high over the Atlantic, and then ridging all the way through, pretty much blocking that off, and then you got the moisture just spilling over with the high clouds spilling over that ridge. So alright, we got the low pressure, high pressure system. Low pressure well to the north. Looks like high pressure well to the north. Strong pressure gradients over the northwest. And we're starting to tighten up over here where this low pressure system is moving through. Let's look at these gradients, but the models are going to be more of a thickness chart, so they're going to show the 500 millibar thickness lines, and then they're going to show the surface pressure. So let's see what happens there with the development of these models, and let's go over there and look and see what happens with the development of these systems anyway. Okay, so all the significant moisture over eastern Texas all the way into Arkansas, Louisiana. It's pretty accurate. These are initialized pretty decent. Moisture to the north over the Great Lakes region, and then just scattered snow and rain showers throughout the northwest. Low pressure system over it's pretty much south. I guess would be more northeast New Mexico on the center, and then southwest or southeast Colorado. So let's watch that low pressure system and see how that moves through. Push it to the north, or push to the east, pretty much directly to the east over to Oklahoma. All that moisture, the thunderstorms push up into out of Arkansas and Louisiana, all the way up into Alabama, Mississippi, and then to Alabama. Low pressure system over Oklahoma, and then just looks like it's starting to kind of die out or push to the northeast. There's still a little. Let's get it back over to our drawing. If I can do this or not. No, that's going to screw everything up. So, all right. So we got. Looks like a closed area over northern Arkansas, and then a low pressure system over Iowa, and then that looks like maybe a frontal system dropping to the south. So we'll see how this thing plays out. The low pressure system moving over the Great Lakes region, and then it looks like a frontal boundary pushing through all the way down through Texas, tail end of that, and then pushing into Louisiana and Mississippi, Alabama, some prefrontal stuff over there in Georgia, and then it just kind of scatters out and dies out on their side of the mountains. So a little bit of isolated storms hanging off the Gulf Coast, and then snow to the north, well up in the southern part of North Dakota. Looks like another little shortwave pushing through, and then high pressure trying to push to the south, so that colder air pushing south, and then ahead of that cold air undercutting that warm moist air from the instability of those low pressure systems that move through. Looks like some showers developing through Missouri, Illinois, and then we do get some more convection off the coast of Florida. Another low pressure system just pops up right there over eastern Tennessee, right over the mountains, drops to the south, Georgia, South Carolina, and then pushes off to the east coast. So high pressure pushes all the way down out of Canada to the south, and then centered over northern Arkansas, drops all the way down to Alabama or Mississippi, and then actually off the Gulf Coast you can see a closed pressure there, and then low pressure develops over eastern Colorado. Another Colorado low looks like it's developing, and that looks like it kind of pushes to the north, and then that's where the model's in. So now we got that pretty significant system over there off the east coast, northeast New England states. Let's see what happens there. That low just popped up over the mountains over eastern Tennessee, drops south over Georgia and South Carolina, right off the coast of North Carolina, and then once it hits that warm Gulf current, then it looks like that low pressure system just explodes, and then pushes up to the northeast and causes wraparound and significant storms all the way back. Wrapping around that low pressure system in the New England states, Connecticut and Jersey, and all the way up through with snow. Looks like pretty significant heavy snow up in Maine. Let's see how keep an eye on that, see how it turns out. So it's 144 hours out. As far as the models are going right now, it's probably doing a model run right now. So there'll be more coming out later, but the South Dakota got another low pressure system. That's actually looks like that pushed out of Wyoming into Colorado, and then back up, just kind of bouncing around right there into South Dakota. So, and then snow showers up in Montana and North Dakota, along with some convection, and like that's where the model's in. So, all right, that's pretty significant low pressure system moving to the northeast, so we have to keep an eye on that thing. You get that wraparound moisture, onshore flow, and instability right there. You can get some pretty significant storms, especially with that snow we pushing on, wrapping around with up in northern Maine. So keep an eye on that thing. High pressure dropping well to the south. I doubt this is anything real cold with a cold core center or anything like that. Nothing gonna be freezing or anything like that. So, all right. So I think I'm gonna end it here with the models, and I want to say thanks for watching, and subscribe to the channel, share the videos, and if you learn anything, just give me a thumbs up. Thanks for watching again.